All right, let's start. So a quick recap of last class. Last class we started the concept of circular motion. So once again, your syllabus only deals with objects going in a circle, a perfect circle. Perfect circle meaning there's no change in radius. There's no change in the rate at which the rotation takes place. So it's a constant circular motion, constant rate. And also it does a complete circle. So you do not have like partial circle, or it just moves in a quadrant. These are also cyclic motion, but they're not circular motion. And we saw that since in a circle you come back to the same place each time, there's actually no benefit in using displacement as a tool. So if you keep coming back to the same place, displacement is 0 all the time. So eventually what will happen is that you don't have a good representation of the motion. So we had to look for a new quantity that properly defines circular motion. And it turns out the thing that is uniform during a circular motion at any given point is the angle they cover. Okay, and I think you remember this blue part here and this red part here, they don't really have same speed. Do you remember? Why was that so? Right? Which one is faster? Yeah, so basically what's happening here, if you look at the circle যদি focus করো, যেটা notice করবা যে a blue pointer makes a circle, right? Obviously, and the red also makes a circle here. However, if you notice, it's a smaller length, circumference com, right? And the red is a longer circle. So what the issue is that দুইটা কিন্তু cover করতে same time লাগে. এটা করতে যে time লাগে, এটা করতেও same time লাগে, because they're part of the same blade. So if I take this blade here, এই যে এখানে ব্লেডটা যদি রোটেট করতে থাকে, every part of the blade কিন্তু একসাথে রোটেট হচ্ছে, but is every part of the blade covering equal length? No, right? So can you tell me which part of the blade here covers the greatest length? Yeah, the circumference, right? The outermost length. But if you keep moving inwards, ভিতরের দিকে, you'll start to notice that the circle is getting smaller and smaller. So the length is getting smaller and smaller. The distance traveled is less and less. So eventually, what was the problem that we faced? The problem that we faced was every point on this blade has a different what? Speed. So if I told you that there's a fan and it's rotating at 10 meters per second, right? What's wrong with that statement? Exactly. It could be any point. It could be two different blades having two different speed, but other common একটা জায়গায় key speed আছে 10. So the problem is it's deceiving for you. So we had to come up with a quantity that's uniform. Uniform মানে হচ্ছে same for any point on this circle. And what is that point? The angle. So if you look at the angle covered here, right? So if it goes from here to there, isn't every single point here covering same angle, right? So instead of looking how far they travel, we look for how much angle they cover. And as it turns out, circular motion যেটা আমরা করব, we'll use angle as our reference. Okay, no more displacement. We'll use everything as an angle. So first thing that you need to learn is time period. Time period কি ছিল? The time taken for one complete oscillation. Angular displacement is the angle. So basically, angle take your angle they call it angular displacement. Okay, how much angle have you covered? And the rate at which you covered the angle is the replacement for velocity. Okay, this is called angular velocity, and we found the equation for it. This one. Okay, so this is your first most important equation in the syllabus. Total charta thakbe. This is the first one. Okay, omega equals to 2 pi by t, or omega equals to 2 pi s. So this is what we did last class. আজকে we will start something new. So definition একটা জিনিস দেখতে হবে. এটা I think তোমাদেরকে জিজ্ঞেস করছিলাম last class, but we didn't write about it. What is a definition for a radian? So it's a very strange requirement on the syllabus dawa. If you'll see here, define the radian. So radian description ta ki tomader jante hobe. I mentioned it last class. Does anyone remember what was a radian? Yeah, so it's a math, and I don't see any need for it in physics, but it's something they ask in the exam. Just 2 marks, So if you have an angle here, theta, and this is your radius, r, right? So radius is r. And this part that you see here, this is your arc length. Arc length usually represent with an S. Are you aware of the formula for arc length? r theta. Okay, so arc length is r theta. So 1 radian is the length, or sorry, 1 radian definition. It is the angle. পাশে লেখা আছে, লেখা দরকার আমি জাস্ট আবার রিপিট করতেছি. It is the angle subtended মানে created, subtended at the center of the circle such that, a part important, such that the radius is equal to what? Is equal to the arc length. Okay, so I'll highlight this. It is the angle subtended at the center of a circle such as the radius is equal to the arc length. সোজা কথা হচ্ছে, if this is equal to that, then this angle is referred as what? 1 radian. Okay, so that's the official definition of a radian. There's no further use of this in our syllabus. Okay, so it's just one of definition acta. I really don't know why they have it here, because it কোনো advantage নাই, এটার কোনো use নাই, but this is something you need to know. So yeah, if your radius here, this is the radius. If this radius here is equal to that length there, তাহলে যে ভিতরে অ্যাঙ্গেলটা জেনারেট করা হয়, that is referred as a radian. Okay, so যে এখানে দেওয়া, the angle subtended at the center of a circle by an arc equal to the radius of a circle. So arc length is equal to the radius. That's it. এখানে আর কোনো extra কিছু দেখার নাই. There's one thing that you might need in the future, and I think I told you about this: how to convert degree to radian. Yeah, so theta by 360 or pi by 180. আচ্ছা, আমি বলে দিচ্ছি. So degree to radian conversion. Theta into pi by 180. Okay, example হচ্ছে 30 degrees, how many radians, right? So 30 degree to radian কি হবে? 30 into pi divided by 180. So how much is that? Pi by 6. Okay, more or less none of the chapters we have utilizes degrees. Everywhere you need to use radian. So radian conversion, keep that in mind, because a lot of students struggle with answering when they forget about the degree conversion. They have their own answer, but they understand the physics very well. It's just they forgot the radian conversion. Okay, so just make sure you convert to radian. Wherever it's angle based, radian convert karo, it's going to be safe. No problem. No, theta, that angle is 1 radian. The angle that's subtended here is 1 radian. Can anyone find me? Can you do the reverse for me? 1 radian is how many degrees? 1 radian is how many degrees? So তোমার একটা idea হবে যে কতটুকু angle cover হয়. Yeah, how many degrees? 50 something. Yeah, I think you said that last class, right? 57.3. Yeah, so for any circle, right? A angle ta 57 point something ashbe when the radius and the arc length are equal. Okay, so that's what the meaning is. Acha, so we are done with the introductory part. Is everyone clear here? Just a couple of things before we move on. What's angular displacement? The angle covered. Okay, what is angular velocity? Yeah, how fast the angle is being covered. That's it. That's all you need to know to move forward. Angular velocity formula, by the way. What's the formula for angular velocity? Yeah, omega is a symbol, is equal to 2 pi by t or 2 pi f. radian to degree conversion now it's just going to be the reverse of this, but degree to radian অনেক লাগবে because আমাদের কোনো math হচ্ছে ডিগ্রিতে করা যায় না আর ওর ডিগ্রি দেয় এক্সামে রেডিয়ান দেয় না, so you always have to convert more or less. Okay, so let's look into another quantity. So page 4 এটা হবে, but আগে তোমরা একটু দেখো what's going on here. So we'll get back to the topic again. So নতুন আজকে স্টার্ট করতেছি, সবাই স্ক্রিনে দেখো কি হচ্ছে. So you have a circle here and there is an object moving in a circle. This is our object and this object is going to go in a circle like that, and as you understand that it is going to cover a certain amount of angle at certain rate. তো আমাদের যেটা জানতে হবে is what is its actual speed. And we talked about this the other day. There's a name for this. What do you call this? The actual speed at which it's moving. Tangential speed. Okay. Tangential speed or velocity. Sorry, speed, velocity, na? Or call it instantaneous. What is this actually? So imagine you're in a car that's going around in a roundabout. Goal করে ঘুরতেছে, তোমার গাড়ির স্পিডোমিটার কি angular velocity show করবে? No, right? What does your speedometer show? Yeah, so it's like speed, actual speed, right? At that moment, what is the speed of your car? ওইটা হচ্ছে is this quantity. It's called tangential speed or instantaneous speed. এটা কেমনে বের করতে হবে? So দেখি. Also, I think I told you last class, on this syllabus, the motion that we're dealing with will always have what speed? Constant. So আমাদের change হচ্ছে না. Yes, real life it can change. We do not have that in our syllabus, okay? The syllabus only deals with constant scenarios. So এখানে যদি velocity v থাকে, এখানেও কিন্তু হচ্ছে v থাকবে. So let's try to find out what this velocity is. So your object goes in a circle. This is the radius, and it goes from here to there. Now, if I want to find the speed of the object, right? Let's say if I want to find the rate at which the object is actually moving, tangential speed, what would you normally do? Let's say একটা O level student কে যদি জিজ্ঞেস করি একটা object হচ্ছে গোল করে ঘুরতেছে ভাবে or speed বের করতে হবে, speed not velocity, what would your formula for speed be? Yeah, distance traveled by time taken, right? What is the distance traveled by an object undergoing circular motion? Complete circle, circumference, right? So distance traveled divided by time taken, distance traveled by time taken. The distance traveled is how much here? If it goes in a complete circle, 2 pi r, right? So 2 pi r divided by, it's a complete circle that it covered, right? Can you tell me what is the time taken? Capital T, it's a time period, capital T. Do you see anything familiar here that we have seen before? 1 by T. 1 by T is what? Frequency. Okay, I'll take that. But there's something more familiar here. In fact, I'm looking for something that you can simplify into. এখানে simplification করার কি কোনো scope থাকে? Which is? Exactly, okay. So I was looking for this one. It's a 2 pi by T. I know it's new, তোমরা last class এ শিখছো, but this 2 pi by T represents what? Omega, okay, omega. So therefore, a very wonderful equation in terms of what you learn in this chapter, v equals to omega r. It will help you solve many problems, okay? Eta hocche the formula of how fast your object is actually moving in terms of speed. V equals to omega r. যেখানে v টা হচ্ছে 10 meter per second হবে unit, omega হবে হচ্ছে radian per second আর radius টা obviously meter হতে হবে. So that's the second formula that we have in our syllabus, okay? Circular motion চারটা formula that you can do everything. So whenever you find angle in your syllabus anywhere, you can just convert into radians because always radians use করতে হয়. So this equation here will help you answer a question we had earlier. At the center of a circle, what is the velocity? 0, right? Do you see this equation helps you figure that out? At the center of a circle, what is the radius? 0. So what should the velocity be? 0. And the further you start to move from the center, what starts to become more velocity, right? Kintu what remains constant though? The omega, the time period, the rate of angle coverage, ওগুলা constant থাকে. So যত দূরে যেতে থাকো তত external যে edge-টা starts to get faster and faster. Okay, so do you guys know what a merry-go-round is? Merry-go-round, but I forgot the name. It's basically called a roundabout. এরকম দেখতে থাকে, playground-এ থাকে, and তোমাদের হচ্ছে something like this. Do you understand what I'm talking about? And it spins around, manually spin korte hoy. So if somebody is standing here, right, and this starts to spin really fast, where do you think the person most likely has to stand so that he may fly off or will fly off easily? The edge. Okay, so anything at the edge will struggle to hold on, but there's a place here where if you stand, you'll never fly off. Where? Yeah, so you can just center thako tale kichu hobe na. Okay, so there are these rides in playgrounds. They go je erokom seat thake and the thing goes in circle khub high speed, right? Oglar moddhe if you stand right at the center, you wouldn't really experience anything. You'll be just going around in a circle. The edge is the worst place out there, and the seats are usually at the edge. Okay, there's ওই জায়গাটার মধ্যে the speed of rotation, right, is the highest. Your velocity is the highest. Okay, the closer you start to move in, velocity aste aste komte thake. Okay, right, so this equation shows it. So as radius increases, velocity increases. Something we'll need in the future, important at the point. As radius increases, the velocity increases. Right, so I think we can try a few questions because the equation is 50% of the chapter. So there's a lot covered. So I'll give you a couple of questions, see if you can answer these. This is just to make you familiar with the equation, okay? So that you have an idea how to apply these. Right, a ball is tied to a string and made to rotate at a constant rate in a constant circle. Constant rate, constant circle. Radius is 40 centimeter and it completes 8 rotations each minute. So let me give you a picture of what's happening. So you have this ball here. It's tied to a string and the string is made to rotate at a constant rate in a constant circle. So circle to a constant. So I'll draw this and show you. I'll introduce a couple of terms for you right now. So first, this is a circle. Obviously, it's cute because I'm not 3D to take this. But এটাও কিন্তু একটা circle. What I'm trying to explain is, okay. So I can take this rope and spin it like a lasso. Do you know what a lasso is? Okay. So that's like helicopter blade motor. So this is also a circle, right? Or I can spin it like this. This is also a circle. Tutor math is extremely different. Okay. Examine the 800 math there. This one, it's 1 mark, right? Or do the 800 math there, it's 6 marks. Okay. So the thing is, how would you differentiate? Because if they just say that it's moving in a circle, it could be either. So there's a word they use. It can be used, but the word is horizontal circle and vertical circle. Okay. So fans spin in horizontal circle or vertical circle? Okay, so the answer is both. Table fan thake na, right? So table fan ki hobe? Vertical circle. So yeah, the ceiling fan is horizontal circle, a table fan is a vertical circle. Do you understand the difference? Vertical circle can complicate it. Vertical circle, as the object moves, right? There's a force that's hindering its motion, gravity, and that's why sometimes it helps, sometimes it doesn't help, because gravity is working against you, and the gravity is. So that's why it becomes 6 marks. But horizontally, gravity is still active, but it's acting which way throughout? Downwards. So it doesn't really change your motion. Okay, so horizontal circle like 1-2 marks. Vertical is like 6 marks there. There's a very good math there, which I'll show. Okay, so yeah, our circle here is a horizontal circle. And এটাকে তোমাকে হচ্ছে constant circle maintain করা হচ্ছে. Constant circle মানে হচ্ছে the circle is a perfect circle here, and you have this rope here, এই যে এভাবে করে ধরে spin করা হচ্ছে. So that's basically the scenario. This is the path, and this is the ball. Okay. So yeah, a ball is taken and spun in a circle like that. কি বলছে at a constant rate. Radius is 40 centimeter. তার মানে হচ্ছে এই রোপটা 40 centimeter এখান থেকে ক্রিয়েট করে from the point of rotation, not the full rope. From the point of rotation is 40 centimeter here, and it does 8 complete rotation every minute. So rotate করতেছে, and it completes 8 rotations every minute. That's the information provided. তোমাদেরকে দুইটা জিনিস বের করতে হবে. তোমাদেরকে ফার্স্টে বের করতে হবে what's the angular speed. Okay, angular speed মানে you're going to find out how much angle does it cover every second. Okay, that's angular speed, omega. And then the tangential speed. Tangential speed কে কি represent করে? The actual speed at which it's moving, right? So দেখো কি আসে. খুবই basic. এটা যদি এক্সামে আসে, it's 2 marks. 1 mark, 1 mark করে. Okay, so but I want you to learn how to use the equation. No, you're not allowed to use fractions or improper fractions, thirds. It's always decimal places. Our team heads up there, এখন থেকে প্র্যাকটিসটা করো. Remember ASA বলছিলাম, but ASA mark কাটে না, এই দুটো mark কাটে. All your answers need to be based on least significant data. You remember practical সে যেটা ছিল বা unit 2 paper 2 তে আমরা মেনশন করছিলাম যে তোমার ধরো লাস্ট এর অ্যানসারটা যখন লিখতে হবে, how many significant figures should it be? What was the rule? Least significant. So আমার যদি 3 significant figure দেওয়া থাকে কোশ্চেনে, and সবকিছু 3 significant figure, your final answer has to be what? 3 significant figure. But what if there's 3 significant figure, 2 significant figure, and 4 significant figure? Final answer কি হবে? 2. Okay, it's strictly followed. So এখন থেকে just make sure you follow that. Okay, make a habit of that. Maybe আমার ক্লাসের কোশ্চেন গুলোতে দরকার নেই, but remember in the exam, in the question paper, they will mark scheme match হচ্ছে না because they follow that. So yeah, is there anyone with answers? 0.8 and 0.3. Why did you choose one significant figure? Which one is that? No, number of rotations. So what is exactly 40? No, just exactly 4 যদি হয়, the exactly 40 যদি হয়, how many significants is that? No, 2. What if it's exactly 40? The other number is just 0 because it's 0, not that I rounded it off. So yeah, a question so don't bother with class যখন আমরা হচ্ছে discuss করব, just try to keep it to at least 2 to 3 significant figures. Okay, 3, 4. Yes, correct. Okay, বাকিদের কি আসছে? আচ্ছা, করে দিচ্ছি. Confusion থাকলে বলো, let me clarify. So angular speed A, angular speed omega equals to what? 2 pi by t or 2 pi f. এখন এখানে একটা জিনিস বের করতে হবে, which is t or f, whichever you want. Okay, how do I find that? So it says 8 rotations every minute. You can use unitary method. Okay, so কি করব এখানে? 8 rotations every minute. So what does that do? 8 rotation in 60 seconds. One rotation is a time ta, what do we call that? What do you call the time for one rotation? Time period, right? So t. So unitary method যদি use করি t equals to 60/8 কত আসে কেউ দেখো 7.5 আচ্ছা 7.5 seconds. So yeah, 2 pi divided by 7.5. How much is it? 0.84. Okay. Unit? Radian per second, correct. Our B হচ্ছে tangential speed v equals to omega r. We already have our omega, so we just need to multiply by the radius. Okay, so that's 2 pi divided by 7.5 into radius is how much? 40 divided by 100, because everything has to be in standardized form. How much is it? 0.34 meter per second. কোথায়? Right. Oh, the rad is actually a ratio of length, so the meter cancels out because radian is arc length equals to radius, right? So they cancel out. Is it clear? Any confusion? Questions that we have established, done. এখন হচ্ছে we'll move on to another part of the chapter. So before I move on, it's a basic part. A basic part গুলো একটু আমরা tick off করে নেই. So define a radian. I think you understand that. Angular displacement in radian express করতে পারো আশা করি. তারপর হচ্ছে understand and use the concept of angular speed. So angular speed টা কি represent করে? How much angle is covered every second, right? So that is angular speed. Recall and use omega equals to 2 pi by t and v equals to omega r. So these তোমাদের কিন্তু equation দিয়ে দেয়. You know that, right? Like in the exam, they give some equations out there. যদি recall বলা থাকে in the syllabus, it means that that won't be provided. So these are the ones you have to remember. Okay? Our বাকিগুলো ওরা যদি বলে use this equation, it means it's already going to be given in the exam. Okay? Right. So that is it. এখন হচ্ছে the crucial part of the chapter. Right. Can you go to page 6? Centripetal acceleration. Okay, this is the business end of the chapter, but this is where things actually get A-level complexity. So it says that understand that a force of constant magnitude is needed. Understand centripetal acceleration is required for a motion. এখানে formula গুলো দেওয়া আছে. So we have a derivation in this topic. Derivation টা করব আমরা. But তার আগে হচ্ছে let's try to understand what do you need for circular motion. Okay, so কিছু লেখো না. Arguably the most important information you need from this chapter is going to be right now. So this is the requirement for circular motion. So if you want to make something undergo circular motion, what do you need to provide? Requirement for circular motion. Now with Cambridge students, it's a little easier because you're not completely unaware of it. You have some idea. Although it's chilo. So for circular motion, there was something needed. Do you remember? Centripetal force, right? And that force had to act which way? Towards the center of the circle, right? আমাদের এখন হচ্ছে we are literally act like, you know, in all sense coming full circle, because we'll learn about that right now, right? So ওইখানে যেটা হচ্ছে, why do we need a force towards the center for circular motion to take place? You have to answer that. And এটা O levels এ ছিল না, it's actually a 4-mark answer. Why do you need a force acting towards the center for circular motion? The centripetal force can দরকার. So I'll start from scratch একদম. I'll assume তোমরা জানো না কোনো কিছু. So look at this. You have a box here, and this box traveling in a straight line, linear motion. Okay, And what we'll do here is we will apply forces. So this is the velocity. And what I'm going to do is I'll apply a force on this object in the direction of motion. So you force apply করলাম. Can you tell me what does the object do in this scenario? Yes. So এখানে যদি দেওয়া হয়, the object will accelerate, or if it's moving against the motion, what will it do? Decelerate. Okay, which is still acceleration kintu, but which way? The other direction. So this acceleration takes place. Question for you is that what happens with the magnitude of the velocity? এখানে যে velocity magnitude direction না, just magnitude কি হয়? Increases. Okay, so velocity magnitude increases or decreases, basically changes. Can we increases or decreases? Yeah, depending on the direction of the force, right? And what about the velocity direction? Same. Okay, this is very important. It is same থাকবে. So this is what happens when the force and the velocity are in the same line. So তোমার যদি force-টা check করে দিকে আর velocity check করে are in the same line, right? So if they're in the same line, there are only two things possible. Your object can speed up or it can speed down. Is there anything else possible? Can it turn and go left and right or anything? No, right? Not possible. আচ্ছা, next হচ্ছে you have same box. And same velocity here, right? And you're applying a force. You're applying a force here. And the force is acting like this at an angle. Okay, so force এইভাবে act করতেছে. So that's your force, F. And this is your velocity. Can you tell me what happens to this object first? For object কি করে? Yeah, so what happens here is because of the force applied, the force actually has two components out there. Remember components? We have components in A levels, okay? It's not going to be part of everything that we do. So there's this velocity here and component arc tailike. One of the components, the red one, is what to the velocity? Same, right? And the blue one is what to the velocity? Perpendicular. One of these components will cause your object to speed up or slow down. Which one? এই দুইটা কম্পোনেন্টের মধ্যে the red and blue এর মধ্যে one of them তোমার অবজেক্ট কে স্পিড আপ করতে পারে বা স্লো ডাউন করতে পারে, কোনটা হতে পারে ওটা? The red one. We just did that earlier. Is it the one that's parallel can make it speed up or speed down, right? So this one can make your object go faster or slower. But what about that component of velocity? Is it acting in the same line or perpendicular? Right. So what will that do? Change direction, right? So এখানে যেটা হবে, because of this force, the magnitude of the velocity will increase or decrease. And what will happen to the direction of it? Same or changes? Changes, right? Okay. So আমরা যদি বের করতে চাই what happens to this object, right? How do you find out which way this object would move? Can you tell me? এই যে অবজেক্টটা আমরা একটু পাশে দেখি, এই অবজেক্টটা কোন দিকে মুভ করবে কেমনে বের করবা? If the force is like this, right? How do you find out which way the object goes? Yeah, vector diagram. Okay, so you have your velocity this way and you have your force that way. So দুইটা use করে তুমি কি বের করবে? Resultant বের করবা, and the resultant is the direction in which your object will go, and most likely the object will go somewhere in between here. এদিকে চলে যাবে. Okay, so it'll turn. I'll give you a simple example of this. Look at this. তোমার হচ্ছে there's this object going like that, right? And you just do that, like give it a strike like that. Object কি করবে? এভাবে হয়ে এভাবে চলে যাবে, right? Do you understand what I'm trying to say? So your object is going in a straight line like that. You just poke it. If you just poke it, will it continuously go in a circle or just move once? Move once and it'll continue to go that way, right? Then you poke it once more, তাহলে কি হবে? ওইদিকে চলে যাবে. And then you poke it once more, তাহলে এদিকে চলে যাবে, right? As you keep poking it every time, what are you applying? Force. And every time you apply force, what does it change? Direction. Okay. So এখানে অবজেক্টটা টার্ন করলো, and this object is now going along that path. Okay, so it's now going along that path because আমি একটা ছোট force apply করছিলাম. Now as I apply force here, so the velocity is going to remain this way. এই যে এদিকে velocity কাজ করতেছে, and I again apply force at another angle. যেভাবে, what will this object do once again? Change direction and also change velocity, right? তোমার কি মনে হয় velocity বাড়বে না কমবে? একটু চিন্তা করে দেখো, এই সিনারিওতে would the object's velocity increase or decrease? Yes, can or decrease? Because if you look at the component now, force is now acting which way? Against your motion, okay? So our object jodi hocche edike jay and this force is acting that way, a force can be break down into two components, right? Isn't one of the component acting the other way? So what will that do to the object? Slow it down, right? So yeah, eventually jeta hocche, let's cut to the chase here. The object will keep changing direction, but the changes in direction will be very random and abrupt, okay? Erom kichu ekta dekhte hobe. But that's not what we want. We want what motion? Circular motion. So let's come to the part that makes it undergo circular motion. So for circular motion, what do we need to do? So circular motion, one very important thing in our syllabus, the requirement is we need the what to remain constant, the velocity magnitude, right? So if your object is going like this, our velocity jodi edike thake, can you tell me how can I apply force so that the velocity magnitude is unaffected? Do I apply force forwards or backwards or perpendicularly? Yes. কেন বলি আমি যদি ফোর্স হচ্ছে এভাবে অ্যাপ্লাই করি তাহলে তো it's going to go which way? Forwards. A component, there's a component, there's a component, there is a component. And when I become perfectly vertical here, is there any horizontal component? মানে যে this is the force I'm applying right now, okay? This is my force. Is there any horizontal component here? So horizontal component was what's necessary to make you go faster or slower, right? Now there's no horizontal component. So what will happen to the velocity magnitude? Remain constant. But there is a force though, and that force and that component is supposed to change what? Direction, right? So jeta hobe, the object, because of this perpendicular force, will change direction, but won't change what? Magnitude. So এই অবজেক্টটাকে তুমি যদি ফলো করো, right? দেখো অবজেক্টটা কি হচ্ছে perpendicularly যদি ধাক্কা দাও, right? It will just change direction and it'll continue with that original velocity in the new direction. So যেটা এখানে আসার পরে যে এরকম করে ট্রাভেল করতে থাকবে, what will the velocity remain? Constant, okay? But it changed direction. তোমরা কি এই পার্টটা বুঝছো? না বুঝলে আমাকে বলো. It's a very important point I'm focusing on right now. আবার রিপিট করি. If you have an object, right, and if your force is in the direction of the motion, তাহলে speed বাড়বে বা কমবে. But if your force is perpendicular to the direction of motion, are you pushing it or are you pulling it, or is it neither? Neither, because you're not pushing it that way. Neither are you pulling it that way, because your force is 90 degrees, right? So it can't make it go faster or slower. The only thing it can do is what? Change direction. And direction change করার পরে, the object will continue at that speed. So we want the object to make a circle, right? But this is not a circle. এটা কি করলে এদিকে এসে এভাবে চলে যাচ্ছে. What do I need to do to make it go in a circle? So আমি আবার force দিলাম towards the center. And it's what force again? Perpendicular to the object. Do you know what would this object do right now? Yeah, change direction again. But তোমাদের কি মনে হচ্ছে that this looks like a circle? Not really. It shouldn't, okay? Because এটা just momentarily কিছু কিছু জায়গায় হচ্ছে আমি ধাক্কা দিচ্ছি, right? So it's not going to go in a circle. So the question then arises, how do we make this go in a circle? So in order to make this go in a circle, right, you want to make sure it changes direction when? All the time, at every given point. So objectটাকে তুমি যদি প্রত্যেকটা ইনস্ট্যান্সে, every single instance you apply a force perpendicular to the motion, what will it continue to do? Change direction, change direction, change direction, right? Any moment you stop, what would the object do? Continue in a straight line, because you have to bring it back in. Do you understand what I'm trying to say? So the object এভাবে যাচ্ছে, force দিলাম, right, like that, it goes like that. Our force দিলাম, it goes like that. Our force দিলাম, it goes like that. But this shape looks more like a hexagon. Do you understand? Octagon, hexagon is straight, dhakka dilam, straight, dhakka dilam, straight. How do I make it into a circle? So every time I hit this, it creates a surface, right? A circle has how many flat surfaces? Not infinite. A circle is a connection of infinite lines. Do you know that? If you zoom into the edge of a circle, you'll find it's what? A straight line. That's what we are experiencing right now. We're on the surface of the earth, right? What does it look for us? The surface? Flat, right? But is it flat? It's not flat, right? It's a collection of many flat lines, which overall would make a what? Perfect circle, right? So how do we achieve that? So finally, for circular motion, what do you need to do? You need to have an object, right? and you need to make sure that the object is experiencing a force perpendicular to the direction of motion, right? At what points? Every single point. And that's why if an object has to undergo circular motion, there must be a force acting towards the center of the circle at all given instances. Does anyone know why towards the center of the circle? It's a O-level question. Yes, the force is perpendicular, but why should it point towards the center? So the requirement is that the force that's acting on the object should act towards the center of the circle. Why do you think the force needs to act towards the center of the circle? I think that's the same thing the other way. But why is it like that? I think what you said is probably right. But does anyone know the reason why it should point towards the center of the circle? That's close. Or maybe my question is not clear. I mean, to boli reason the key. Reason ta hoche, O-level se, there was a chapter. I don't know if it's there anymore. It's called Locus. Locus আছে তোমাদের? Yeah, I mean, করার কথা, it's something very basic, okay? ওই যে perpendicular bisector draw করা, তারপর হচ্ছে line কে half split করা। আচ্ছা, না থাকলে problem নাই। আমি বলি কি, it's a circle thing. একটু শুনো এদিকে। I'll start with basics, don't worry. There's a name for this line. What is it? It's a shutra, right? Achha. So there's a requirement in math that if you have a tangent and you draw a line perpendicular to the tangent, ওটাকে বলা হয় normal. Okay? So there's a requirement in math that any circle, if you take two normals, they will always pass through the what of the circle? Center. And normal key, normal হচ্ছে a line that is perpendicular to the surface of the circle. আমাদের যে force গুলো draw করতেছি, they're what to the surface of the circle? Perpendicular. So they are bound to point towards the what of the circle? Center of the circle. So that's the math behind it. Okay. So whenever your object is going in a straight line and you apply a force perpendicular to it, a straight line taking into tangent, and your force is what to that tangent? Perpendicular. So what we call that? A normal. So it is definitely going to point towards the what of the circle. And that's the reason why if you want a perfect circle, your force must act towards the center of the circle. তোমার যে সেন্টার থেকে একটু deviate করে কি হতে পারে বলতে পারবা? It's center দিকে, but center not. What will happen to the circle? Velocity will change, but can you describe the shape? What might happen? Yes, exactly. It will become something like this. Why? Because isn't it getting pushed out a little bit because of that extra velocity out there? So it will basically become like an oval or something. It depends on how the force is changing. Okay, so if you want a perfect circle, your force has to act towards the center, and this force that acts towards the center of the circle is what we represent as what force? Centripetal force. Okay, this is a very important word. Centripetal force. This is needed for you to be in a circle. Okay, there's another word out there, very popular with everyone. What is it? Centrifugal. Okay, let me clarify this as early as possible. Centrifugal force is not a force. It doesn't exist in physics. Okay, it's a word made up by I don't know whom, but it's wrong. It doesn't exist in physics. So I'll explain why. There's this device called a centrifuge. Where centrifuge ki kora hoy is used to separate different types of particles. Blood ke separate kore from the water inside it. You probably have heard in chemistry or biology, I don't know where, but basically spin kore jinishta spin korte korte সব কিছু বাইরে দিকে চলে যায়। এখন ওই ডিভাইসটার মেকানিজম বোঝানোর জন্য to non-physics people, the people who came up with the concept, came up with the term centrifugal force, that the force that's against centripetal force acting the other way, right? Why is it wrong? It's wrong because I'll tell you right now exactly why it's wrong. Centripetal force is acting towards the center, right? People think centrifugal force is the force that's acting which way? Away from the center. Do you know if that's true? What is the net force on the object? Zero. Where would it go? Straight. So it's not going straight, right? Which means centripetal force is a what force? A net force. There's no pair to it acting the other way. And do the pair act করে থাকে, it will be acting on the other object that's experiencing the force. Let's say there's a rope, the rope is pulling the ball, and the centrifugal force, so-called, would be the ball pulling the rope. Two different bodies, okay? but it is still centripetal force at third law there, not a centrifugal force. So if you ever get the temptation to use centrifugal in your answer, right, it'll be wrong. You won't get any marks. Achha, don't use that. It's not a physics word. You can search online. It's clear everywhere. It's not part of physics. It only get used for it, but we won't be using it. Okay. So there's no centrifugal force out there. There's only one force. That's the centripetal force. So yeah, this is the evolution of it. So I'll do a quick recap of it. If your force is acting in the direction of motion, there's only change in magnitude, no change in direction. If your force is acting at an angle, then there's change in magnitude and there's change in direction. But change in magnitude, the object won't make a circle. So only if there was a possible way where my velocity would remain constant, but what would only change? And that can only happen if your velocity and force are what to each other? Perpendicular. And if that happens, it will only change direction, not magnitude. But I wanted to go in a circle. So I wanted to change direction every time. That means I need to have a force acting on it every time. And that force that's acting on it every time towards the center is what we call centripetal force. And it makes sure that the object continuously moves in a circle. Okay? Right. So this is it. If you want to draw any of them, draw korte paro. Question takle bolo. There is, but not on the object. It's on the other object that applies the force. So if you draw a free body force diagram, right, the other system that's applying the centripetal force has to be taken into account. Without that, you can't show it. So it's not acting on the same object, which is the misconception out there. Okay, so there must be a pair because Newton's third law states that for every force, there must be some pair out there. The pair is not centrifugal force. Okay. A net force, which is because it's the only force acting here. There's no other force there. Two forces must act to be a net force. It's a resulting force. Oh, this is the only force. But I'm using a box snake and I'm using a COT. Velocity. No, somewhere, but something. Something from somewhere. अच्छा क्लास शेष ना তোমরা কই যাচ্ছ কেন তো বই নেই ক্লাস শেষ আচ্ছা একটু এটা দেখে নাও before I wrap up. So every instance here I've given like a point here. So when the force and the velocity in the same direction, the object only accelerates. First scenario. Second scenario, so when the force and velocity opposite direction, it is basically the first point together. What happens when your force is acting the other way? It decelerates. So you have your acceleration. Or do you force ulta dike ek kore? What does it do? Decelerate. But if your force is acting at an angle, then there will be change in velocity and also what? Change in direction. But we want a perfect circle. And perfect circle, velocity and magnitude can't change. That's a requirement. So talking about number 4, when there's a force acting only towards the center, the object changes direction continuously and hence it undergoes circular motion. There is no change in what? The magnitude of the velocity. Okay. But generally, I'm not mentioning because velocity actually changed. Can velocity change? No. Because there's change in direction. When I'm magnitude but if they ask you in a circular motion, does velocity actually change? What's the answer? Yes. Okay. So in magnitude আমি বলি, but exam যখন eventually জিজ্ঞেস করবে does velocity change or not, কিন্তু আলাদা করে বলতে পারো না magnitude change হচ্ছে না, you say velocity does change. Okay, because there's a continuous change in what? Direction. Okay. Now, before we wrap up, I have a very simple question for you. There's change in velocity. Do you agree? like as it goes in a circle, magnitude, direction, সব মিলে. Is there a change in velocity? Yes, okay. And the change in velocity takes place over time, right? If there's a change in velocity that takes place over time, what does that result in? Acceleration, because acceleration is a rate of change of velocity. Do you agree so far? So there must be acceleration. And if there's acceleration, there must be something else. Whenever there's acceleration in the universe, right, there must be something to provide acceleration, a resultant force. And that force is what? The centripetal force. Okay, so that's the origin of the centripetal force. So there's a reverse argument here. Reverse argument হচ্ছে, if something goes in a circle, it is continuously changing what? Direction. And because continuously changing direction, there's a continuous change in what? Velocity. And that change in velocity takes place over time, which means there is what being experienced? Acceleration. And to provide acceleration, what must be needed? A force. And that is the force that is needed for your circular motion. Okay, so that's the 4-mark answer. Eta হচ্ছে next class properly আবার বুঝাবো. But do you understand the origin of it? Why is the force needed? Okay.